Everyone, hello and welcome. Today we're going to work on another projectile motion practice problem. In this case, we have an artillery shell which is fired from the ground with an initial speed of 1.7 times 10 to the third meters per second. That's 1,700 meters per second at an angle of 55 degrees with the horizontal. What is the time that the shell is in the air, and what is the horizontal range of the shell? So in this case, we have a projectile which is fired at an angle. Okay, and so it is fired at an angle upward, and that angle is 55 degrees above the horizontal or above the horizon. So if this is the ground, and we imagine rotating up 55 degrees, that is the angle that this projectile is fired at. All right. So the first thing I'm going to do is write down my givens and draw my picture. So I've got a picture here of our vector, and this vector has a magnitude of 1,700 meters per second. And I'll write that down right here. VI equals 1,700 meters per second. Now, we need to break this down. Remember that with projectile motion, we have to work our problems separately. We have to work it in the x and the y dimensions separately. And so what I need to do is I need to break down our initial velocity, which is at an angle, into how much of that is in the x dimension and how much of it is in the y dimension. And so we'll do that in just a second. First, I'm going to draw our vectors in place, and that's going to be the velocity in the x direction, and this is going to be the initial velocity in the y direction. All right, and so the question is, how can I find the values for Vx and Viy? And we're going to do that using our trig functions. Okay, so what I'll do is I'll look at my opposite side, which is Viy, and I'll solve that with the sine function. All right, so right here, sine of theta equals opposite over hypotenuse. In other words, hypotenuse times sine theta equals opposite. And so h is 1700, the value for our hypotenuse. Sine, and our angle is 55 degrees. Sine 55 equals the opposite side, which is VIY. Okay, and so our initial velocity in the y dimension will be, if I punch that into my calculator, I get 1,392.56. So I'll just put 1,392.6. Okay, and that is, of course, meters per second. Now, let's go ahead and do the exact same thing, but with our cosine function. So cosine of theta is the adjacent side divided by the hypotenuse. So again, hypotenuse cosine theta equals the adjacent side, and so 1,700 cosine 55 equals our velocity in the x dimension. Notice that I didn't put initial or final, and that's because, remember, there is no acceleration in the x dimension, and so it is both our initial and our final, because since it doesn't accelerate, the velocity never changes. And so we have one value for that the whole time. And Vx is going to equal, punch that into the calculator, 975.1 meters per second. Okay, I'm going to go ahead and write down my other givens now as well. Remember that my acceleration in the x is 0 meters per second squared. My acceleration in the y is negative 9.8 meters per second squared. And so we have that. Let's see. It wants to know what the horizontal range is, so it wants to know what the displacement in the x is. And it also wants to know what time is. And so I don't know what my time is, and I don't know what my displacement is. Now that means that I don't know time for the y either, because those are the same. And I do know the displacement in the y direction, and that's because it actually lands back on the ground, which means that the total displacement is 0 meters. All right. So at this point, I actually do know my final velocity in the y dimension. Remember that since it goes up and comes down to the same height, the final velocity in the y dimension is the same as it was as the initial velocity, except it's negative 1,392.6 meters per second. All right. So with that in mind, I know literally everything in the y dimension except time. So let's use our y dimension in order to solve our for our time. I'm going to choose a different color. Let's go with a nice blue. And I'm going to choose VF in the y. VF equals VI plus A times t. Notice that everything is in the y. Remember that when I'm working in the y dimension, I have to use all y values. I cannot use anything from the x side, and I can only use y values. So negative 1,392.6 equals 1,392.6 plus negative 9.8 t. All right, I'll swing that across, and then I'll divide by 9.8, and I'll get that t is actually equal to 284.2 seconds. So t is equal to 284.2 seconds. And that is a long time. That's several minutes. But remember that we actually shot this projectile at around 5 times the speed of sound, so it makes sense that it would be in the air for a long time. So the time I can put as 284.2 seconds. And that is the same on both sides. Remember that time is the only thing that is the same for both. And that is how long the shell is in the air. So I've answered my first question. Now I just need to know what the horizontal range is. Remember, the horizontal range is how far it travels in the x dimension. And so what I'll do is I will choose my delta D equals VIT plus 1/2 AT squared. Now, when I put in my acceleration in the x dimension, remember it is 0. And so when I put that in, that's going to zero out this entire term because all of these are multiplied by each other. And so the acceleration will zero out that entire term. So I'm really just going to be left with delta D in the x dimension is equal to the velocity in the x dimension times the time in the x dimension. And of course the time is the same in both dimensions. It's 284.2. When I multiply those, I'm going to get that delta x is 277,000 113 meters. That is a long way. It's 277 kilometers, which is which is around 200 miles. So, that went a long way, but that's what we expect again from artillery shells that are fired at 1700 meters per second. Um, all right. So there's our time and there's our distance. Thank you very much, and I hope that's helpful. Just remember, anytime you're working projectile motion, to always separate your x and y. What happens in the x stays in the x. What happens in the y stays in the y. And the only thing that can mix and cross back and forth is our time. All right. Thanks so much and have a great day.